Hello, my name is Farhan Shakil and I am from the Republic 2.0, and today we're going to talk about an important topic from chapter number 2 of Edexcel AS level maths, Pure 1. So the topic is the quadratic graphs, and many students are having difficulty while talking about this topic. When you're talking about the quadratic graphs, first of all, you need to understand what type of a quadratic equations you can come across. For example, first of all, you can come across a quadratic equation that looks like y is equals to negative ax square plus bx plus c. Then the equation can also look like ax square plus bx plus c. The only difference in these two equations is that you've got a negative coefficient of x square over here and you've got a positive coefficient of x square over here. Thirdly, you can have negative a y square plus by plus c. And then you also can have, you know, f of y, this is a function, and then f of y would also be equal to positive ay square plus by plus c. So you've got these three equations. The first two equations are in terms of x, the last two equations are in terms of y. So first of all, by just looking at the equation, you can have a layman's knowledge about the shape of the graph. If you have got negative ax square plus bx plus c, or you have got ax square plus bx plus c. Negative means the graph should be opening. Everybody knows that the graph of the quadratic equation looks like a parabola. If you have got negative ax square plus bx plus c, the graph would open downwards. If you've got ax square plus bx plus c, remember that the graph of the parabola should open upwards. If you've got negative ay square plus by plus c, you need to remember that the graph would be opening leftwards. If you've got positive ay square plus by plus c, remember that the graph should be opening rightwards. So that is the shape of the parabolas depending upon the type of equation we are having. The next important thing, if you're talking about a parabola, the important thing about the parabola are its x-intercepts, the y-intercepts, and the parabola. For example, if you have got this equation, something that looks like you've got this, and then you've got an equation that looks like somehow this, right? The important points that you need to know to draw any graph of the parabola are these important points. This point, first of all. This point is known as the y-intercept. Similarly, whenever you're talking about this point and this point, these two are the x-intercepts. So while talking about the parabola, you need to know these x-intercepts. And this point, you can see that this point. This point is the turning point, which also we need to know that this is a turning point. And remember that the equation of the line passing through this turning point is known as the line of symmetry of a parabola. So this is the line of symmetry of the parabola. So remember that whenever you're talking about the parabolas, you need to know all these thingies to get yourself the full marks, right? Now, for example, if you're having an equation that looks like, if you're having an equation that looks like x square negative 5x plus 4. So given that x square negative 5x plus 4 equals to 0, I've got this equation and I need to draw a graph, a quadratic graph of this equation. So what I'm going to do, first of all, for x-intercepts, I'm going to find out the x-intercepts. So if you're looking for the x-intercepts, this equation would look like, if you're looking for the x-intercept, you just need to plug in y is equals to 0. So you would be having y is equals to x square negative 5x plus 4. Keep it equal to 0. So you should be having x square negative 5x plus 4. And then you can also write it like x negative 5 times x negative 1, if I'm not wrong. No, it is going to be. So if you're looking for this equation, we can simply write it down like x negative 4 times x negative 1 equals to 0. So I've got the two x-intercepts, which comes out to be x is equals to 4 and x is equals to 1. So this is how we're going to get ourselves the x-intercepts. Similarly, you also need the y-intercepts. So for the y-intercept, if you're talking about the y-intercept is going to be y is equals to 0 square, negative 5 times 0 plus 4. And you should be having y is equals to 0, negative 0 plus 4. So y-intercept comes out to be 4. So you've got the y-intercept, you've got the two x-intercepts, and the third important point while talking about any quadratic graph is to calculate the turning point. So for the turning point, remember that to determine the turning point, we need to write our equation in a completing square form. If you have got y is equals to x square negative 5x plus 4, how can you determine the turning point? By just writing it like in a completing square form, and you should be having x negative 5 by 2 ka square negative 5 by 2 ka square plus 4. So you should be having y is equals to x negative 5 by 2 ka square negative 25 by 4 plus 4. And you should be having y is equals to x negative 5 by 2 ka square. And then over here, it is going to be negative 25 plus 16 divided by 4. So you should be having y is equals to x negative 5 by 2 ka square and then negative 9 divided by 4. So that is this equation in a completing square form. So now you can just compare it with x plus p square plus q. You can just compare it with x plus p square plus q. And remember that the p from here is going to be negative 5 by 2. And q from here is going to be negative 9 by 4. And remember, the turning point would always be negative p and q, right? That is a formula for the turning point. So you should be having a turning point which should be 5 by 2 and then negative 9 by 4. So that is how I'm going to get myself the turning point of any quadratic equation. So for example, if you want to plot this information, you've got the two x-intercepts, and these two x-intercepts are 4 and 1. So you have got 4 and 0, 1 and 0, and then you have got a y-intercept. The y-intercept is 0 and 4. And then you have got a turning point, which looks like 5 by 2, and then negative 9 by 4. You have got 5 by 2, and then you have got negative 9 by 4. If I'm just going to plot it roughly, when you're talking about the x-intercepts, first of all, just locate the x-intercepts. If you're talking about x-intercepts, there is an x-intercept 1 and 0. For example, this is 1 and 0. This is somehow 4 and 0. And then the y-intercept is 0 and 4. So 0 and 4 must be somewhere over here. And then you have got the turning point, which looks like 2.5 and then negative 2.25, right? This is the turning point in the decimals. So you can see that 2.5 must be lying somewhere right in the middle of these two numbers. And then you've got this negative 2.25. So negative 2.25 is going to be somewhere over here. So this is going to be the turning point. This is going to be the x-intercepts. And this is going to be the y-intercept, right? And now I'm just going to join all these points. And remember, if you remember, the coefficient of x square was positive, right? So my parabola must open upwards. So this is some rough sort of shape of the parabola. Now you guys must be wondering that how can we determine the line of the symmetry? So you can see that you've got a line of the symmetry passing straight in the between of 1 and 4. And the midpoint of 1 and 4 is going to be, this midpoint is going to be 4 plus 1 divided by 2. That is the value of x. X should be 5 by 2, right? So when you're looking for the line of symmetry, it has to be x negative 5 by 2 equals to 0, or it could be 2x negative 5 equals to 0. So that is how we plot such quadratic graphs. Now we're going to practice one more example related to the quadratic graphs. And this example is going to be, let me take you back to the book. Okay. Now, if you could see, you've got this 2f, and we're just going to talk about this I part, right? We need to sketch the graph of the following equations. For each graph, we need to show the coordinates of the points where the graph crosses the coordinate axis, write down the coordinates of the turning point, and equation of the line of symmetry. We have learned how to do all of these thingies, and now we're going to do this again for a difficult, a sort of a comparatively different question. So I'm just going to copy that question over here, and I've got y is equals to 4 negative 7x negative 2x square, right? You've got y is equals to 4 minus 7x negative 2x square. So first of all, for x-intercepts, I'm going to talk about x-intercepts. So for x-intercepts, I'm going to use equals y is equals to 0, 4 negative 7x negative 2x square. And now I can just rewrite this equation to look like 2x square. Negative is positive. Positive 7x negative 4 equals to 0. Now you can see that, 2x square plus 7x minus 4, the factors are going to be 2x and x over here. Now 4 times 2 is 8. We need to think about two numbers which are going to give you 7. So I would be having 2x plus 8 and then x minus 1, right, equals to 0. So I would be having right now, x is equals to negative 4 and x is equals to 1. So these are the two x-intercepts that I should be talking about. Now the next thing is for the y-intercept. If I'm looking for the y-intercept is going to be 0 is equals to 4. Sorry, for y-intercept, we need to plug in x equals to 0. So y is equals to 4 minus 7 times 0, negative 2 times 0 square. So I should be having y is equals to 4. So I've got the y-intercept. I've got the x-intercept, which is negative 4 and 0. I've got the x-intercept 1 and 0. I've got the y-intercept, which is 0 and 4. Now the next thing that I'm going to do, I'm just going to calculate the turning point. So for the turning point, if you guys remember, we are going to convert this equation in a completing square form. So first of all, I've got y is equals to negative 2x square, negative 7x, positive 4, right? And then, what I'm going to do, y is equals to negative 2s common from the terms containing x, and I would be left out with x square plus 7 by 2x plus 4. That is how we're going to take 2s common. Now I'm going to write this equation in a completing square form. So I would be having y is equals to negative 2. And this would become x plus 7 by 4. Half of 7 by 2 is 7 by 4 square. Negative 7 by 4 square. Bracket close. And then at the end of the day, I'm having plus 4. So now the equation would look like negative 2 times x plus 7 by 4 plus 2 times 49 divided by 16 plus 4. So I would be left out with a negative 2 times x plus 7 by 4 square. There is a square over here as well. And it is going to be 49 divided by 8 plus 4. So y is equals to negative 2 times x plus 7 by 4 ka square plus 8 4s are 32. And 32 plus 50 is going to be 82. So it is going to be 81 divided by 8. So by comparing it with a times x plus p ka square plus q, I would be having p as 7 by 4 and I would be having q as 81 by 8. And now turning point is going to be negative 7 by 4 and 81 upon 8. If you remember, the turning point was negative p and q, right? So that is how we're going to get ourselves the turning point. Now to plot them out, we need some additional information, not the additional information, but we need the x-intercepts. We had the x-intercepts as, if I'm not wrong, negative 4 and 1. So negative 4 and 0, 1 and 0. I've got the x-intercept, which was 0 and 4, if I'm not wrong. Exactly. 0 and 4. And then I had the y-intercept. I had the turning point, which was negative 7 by 4. Negative 7 by 4. And then it was 81 by 8. Yep, I had 81 by 8. So first of all, I'm just going to locate all these points. So if you guys remember, -4, 1, 2, 3, 4. This is going to be -4 and then 1. So I am looking for these two x-intercepts. Then I've got the y-intercept, which is 0 and 4. 0 and 4, 1, 2, 3, 4. So this is going to be 0 and 4. Then I'm looking for -7/4, which is something like -3.75. So -3.75 must be lying somewhere over here, right? And 81/8 is something like 10.1 or 10 point something like that. So along the y-axis, 5, 6, 7, 8, 9, 10. So this is going to be 10, which is 10 point something. So I would be having a point over here. So this is the point that I would have been looking for. So now the graph would look like somehow like this, right? I've just plotted a random function. I've just plotted it on the roughly. That is what the shapes looks like this. Otherwise, it should have been a pure parabola. Okay. So that was this kind of question. They are very important for the PO1 exam. If you've got any questions from these, all these, if you've got any questions from this topic, you may ask it in the comments. Thank you very much.